So in this video, we're going to discuss inductive reasoning. By itself, inductive reasoning is not listed within the standard, but it is a tool that you will use to address proof, and the proofs are within the standards. We have two objectives. First of all, use inductive reasoning to identify and describe patterns to make conjectures, and also use a counterexample to disprove. Our three vocabulary words, which I expect most people are not familiar with: inductive reasoning, a conjecture, and a counterexample. At its most basic level, inductive reasoning, which is, of course, the focus of the entire topic today, inductive reasoning is really nothing more than working with patterns. How do you think about patterns? How do you recognize them? How do you describe them? And so we'll start here and say, what's the next item in the pattern? Okay, so we're saying July. How do you know that's correct?
Oh, it skips one every time.
So we had January, skips March. I'm sorry, January skips February to get to March, skips April to get to May, skips June to get to July. That's inductive reasoning. Just looking at it and recognizing a pattern is inductive reasoning.
Oh.
What about this one? What's next in this pattern?
Yeah.
35. And how do you know? Because our pattern is just adding 7. Looking at the item, identifying the pattern, and continuing a pattern, that's inductive reasoning. What about here? What's next? So what's the pattern then? What's happening to the shape? It's rotating toward the left each time. So top rotates to the left, rotates to bottom, bottom rotates to right. This is inductive reasoning. Spotting a pattern, continuing a pattern. In terms of the textbook stuff, and once again, I don't expect you to write all these things down, inductive reasoning is identifying patterns, and we're going to use the patterns to make some kind of a conclusion. We're going to say, here's something that I think is true, and I'm using a pattern to figure it out. That's all inductive reasoning is. The statement that we say, I think is true, that's a conjecture. A conjecture is really nothing more than a guess at what you think is true. I think this thing is true based on this pattern. You see how it's tying to what we were doing before?
Yeah.
Well, make a conjecture. The sum of two positive numbers is, take a guess, what do you think? Okay, I'm having some people tell me is a positive number as their guess. I'd like another guess, and I don't care if the guess is right or wrong, I just want to guess for something else. Okay, these pieces are examples of conjectures. We're taking a guess at something that we think is true. And when we guess, sometimes we can guess correctly, sometimes we can guess incorrectly. This one, of course, we know that you can't add up positive numbers to get a negative. What about here, though? The number of lines formed by 4 points, and none of them are collinear, so we don't have 3 points in a row anywhere. How many lines can be drawn? I'd like you to write down your conjecture and show me. So what guesses do we have? I have 6. I have 4 for conjectures. What else? I have 7 as a guess. We have 5 as a guess. All right, so we have lots of different conjectures here. We could try a drawing and simply say 1, 2, 3, and 4.
So write a square on the board.
When we start to draw them, there's 1 line, 2 lines, and 3. We connect these ones to make 4. Connect these ones to make 5.
And the bottom one.
And bottom, there's 6. Based on this drawing, I have 6.
Can you do more?
Now, is this going to be true for every single set of 4 points you can draw?
No.
No.
Well, this is where we're looking at it. We have one drawing. If we wanted to, we could draw another one, see how many it works out. Take a third drawing, see how many lines come out. If we continued drawing after drawing after drawing and we could spot a pattern, then we'd have a little bit of evidence that we think our guess is correct. Right now, we're just saying, based on this one piece, one drawing, we're going to guess, take a conjecture that it's 6. We're done with the problem. All we're doing is making a guess. What about here? The product of 2 odd numbers is, okay, we have a guess for even. We have a guess for odd. These are examples of conjectures. We don't know immediately if we're right or if we're wrong. We would have to do some further investigation. But we could make our conjecture. Now we want to continue further noting, if you remember our priority standards, the must-have things that we need for geometry, 5 out of 6 of them were word problems. So we know word problems are the most important thing in any time we're doing anything. They're the most important. This is our most important problem right now. Read through it. A cloud of water leaving a whale's blowhole when it exhales is called its blow. A biologist observed blue whale blows of 25 feet, 29 feet, 27, and 24 feet. Another biologist recorded humpback whale blows of 8 feet, 7 feet, 8 feet, 9 feet. Using your boards, make a conjecture. And I'll pause the video here. Recognizing types of conjectures that we can look at, one possible guess, based on using the numbers, the smallest blue whale blow was 24, the largest humpback blow was 9, and so one possible conjecture, well, we could take 9 times 3 and get something a little bit bigger than 24. One possible conjecture is to simply use an equation and say it's about 3 times as big. The one that I showed didn't get into equations, we just simply said it's bigger. Those are good conjectures. They're things that we would want to investigate. Now, just because we've made a conjecture, that doesn't always guarantee that it's going to be correct. I'd like you to make another conjecture here. Based on the data, make a conjecture. Write it out. I'll pause the video while you write. And the answers that I'm seeing, most people are throwing out guesses, some or conjectures somewhere along the lines of females are bigger than males or longer than males. Now, one of the difficult components that we'll have to get used to, if you want to declare a conjecture is definitely true, we need to have a proof. Proofs are generally more complex. There's usually a lot of work involved in proving something is true. Most of the time, it's easier to actually show something is not correct. If we have a conjecture and it's actually wrong, we don't need to show a million examples where it's wrong. If we make a statement like females are always bigger, it only takes one example to show that it's not true. That one example showing something is not true is called a counterexample. For instance, we could make the statement all babies are cute. That's my conjecture. How would we prove that false? Yeah, you'd have to find one ugly baby. You find one ugly baby, and we have a counterexample proving that not all babies are cute. When we provide a counterexample, it can be anything showing the statement is false. You can use a drawing. You could use a statement. You can use a number. Anything that shows the statement is not true will serve as a counterexample. By and large, inductive reasoning is going to follow the path where you will search for a pattern and then make a conjecture based on the pattern you see. That doesn't guarantee that you're going to be correct, though. So after you make your conjecture, you'll want to either prove it, that's one of our critical standards that we'll work on throughout the year, or try to find a counterexample showing that your guess didn't actually work. For instance, for every integer, n cubed is positive. That's actually not true. Let's come up with an example that shows it's not true. This says for every single integer. We find one of them where it's not, and we're done. And so the first one that they came up, that the student told me, was -2. If we take -2 cubed, -2 times -2 times -2 equals a total of -8. And since that is not positive, we're already done. This stuff in the purple is a counterexample. It shows the statement is not true. We found a number that shows it doesn't work. What about here? Two complementary angles are not congruent. What kind of an example could we come up with that shows that this is false? Well, we have to start by saying what is complementary. And you've got it. Complementary means that the angles add up or they sum to 90 degrees. So can we come up with two angles that add up to 90 degrees, and those angles, well, this one says they're always not congruent. Can we find angles that are congruent and they add up to 90? What angle would do it? And some students are telling me a 45-degree angle would do it. 45 plus 45 will equal 90. So they're complementary. They're both 45, so they're congruent. Here's a number that would provide our counterexample. We could do the exact same thing with a drawing. Here are two angles that are complementary because they make a corner. It's pretty obvious, though, that these two angles are not congruent. We need an example where they are, so we come up toward the middle. And especially if we draw in some kick arcs, there. We have two angles. We know that they are congruent. We can see that they form a 90. The drawing is enough to say that this conjecture is false. We could have also used the number for 45 degrees to show it's false. There's more than one way to do it. What about this one? Pause the video, write down your answer, let's see what you've got. Looking at the answers that the students are giving me, a lot of people recognize January and February are consecutive months. The average high temperature is below 90, so January and February by itself, that is already enough of a counterexample. Several other students, though, noted that December wraps it around into January. And so we didn't just have 2 months in a row. December followed by January followed by February. There are actually 3 months in a row where the average temperature is below 90. The average high temperature is below 90. So the question was asked, why can we use December and January? Because they're in different years. Our conjecture doesn't say anything about in a calendar year. They just say months in a row regardless. And December followed by January are months that are in a row. Wrapping around to 2 different calendar years, but they're still in a row. I'd like to go back and verify the skills that we were going over. There are 5 basic types of skills that we're working with. First of all, can you recognize and follow a pattern? Based on a pattern, can you make a conjecture about something you think is true? Can you do that in a word problem?
Yeah.
And can you provide counterexamples showing that something is not true? That's really all that we've got. That finishes this particular one off, and we are done for the day.